In recent years, healthcare organizations have embarked on turning big data into a competitive advantage. The challenge of extracting values from big data is the process used to extract data from multiple sources, transform it to fit your analytical needs, and load it into a data warehouse for subsequent analysis. And this process is known as extract, transform, load, or ETL. A traditional ETL process extracts data from multiple sources, then the system cleans, format, and loads the data into a data warehouse for analysis. First, we must determine the default method for extracting data from each source system. Before the data is being extracted, it must be archived. Next, data quality must be monitored during the ETL process rather than waiting for business user to find data problems. In order to ensure that the data warehouse and the ETL system meet the system availability requirements, each data source must be documented as it becomes available. Transforming data is necessary because it makes the data easier to work with. Applying good data transformation will yield reusability, consistency, and improvement of overall performance. This figure illustrates an ETL modeling process for Unlock Senior Health Services. It is essential that Unlock can draft a dimensional model to streamline the health information database. For the dimensional model that Unlock is creating for the health information library, the business processes identify operational activities performed by clinical services, such as taking a drug prescription order, distributing instruction on prescription drug use, providing health education brochures, or medical instruction from doctors and nurses during patient encounters. Therefore, the critical decision to create a dimensional model for patient encounters by considering multiple dimensions such as time dimensions, the patient dimension, the document dimension, and the employee dimension. The work group responsible for developing the model has selected the star schema approach to this dimensional model. Problems can occur when gathering requirements and design activities are not done correctly. Poor data quality is the most significant contributor to delays in the ETL portion of the project. This happens when the data is not supporting business rule, the data is incomplete, or source data structure do not comply with the design. If the project is managed in an iterative manner, it is a good idea to limit the set of requirements in the beginning. The first iterations would only include requirements for bringing in transactions at the most granular level with a limited set of dimensions. Then later iteration could refine these requirements to add summary, complex dimension, and hierarchy. Leveraging the data modeling tool. A data modeling layer is a system that contains the mapping between business logic and underlying data storage rules of the business. It exists primarily in the ETL design, where data is loaded into the data warehouse first before being transformed. This is a contemporary approach to orchestrate transformation within the data warehouse via tools that connect directly to the data warehouse. These tools allow the act of transforming data from old tables to new ones. They also permit users to annotate, manage, and track changes to data models over time. Non-technical users should be able to log in, interact with some user interface, and get the analytics they need. Leveraging the data profiling tool. Data profiling is the process of verifying business rules and data integrity, monitoring the data quality in the source systems, and validating it against the requirement and business rules is essential for preventing problems with the data later in the ETL process. From one-time scan to regularly repeated scan data quality in a given system is reviewed and analyzed to understand the structure, content, and the implicit or explicit business rules. The primary objective of data profiling is to provide a deep understanding and insight into the details of a given collection of data. Many different technologies are being used in modern enterprise data management environments. More and more data are stored in traditional databases, analytic cubes, or in the cloud. Therefore, it is necessary to be familiar with each of these data management products and their strengths and weaknesses. Every data stored across an enterprise requires database administration and maintenance. Typically, these functions and the tools used through which to perform those tasks resides in the realm of database and system administration professionals. With advances in today's EDM technology, data virtualization is gaining traction in the EDM roadmap of many organizations. In addition, master data management and metadata management must receive significant attention through an EDM roadmap initiative. Data governance for big data should be an extension of the approach used to govern all enterprise data, embracing privacy and security, compliance, and data quality.